Hi, and welcome to this video on personalized dialogue management. Have you ever tried a conversational interface such as Siri, Google Assistant, or Alexa? And are you still using it on a monthly or even daily basis? Think about your experiences with it. Did you use it to look up basic facts or give it simple commands? Did it strike you as capable of restoring earlier mistakes, or did you feel it was adapting to you? Would you trust the advice such a tool gives you? In this video, we'll talk about how you could make such a system adapt to a particular user using reinforcement learning. In order to do so, we'll first have a more detailed look at a dialogue system. Here, we see an example between a user and a dialogue system. The user first explains that they want to book a hotel, after which the system responds by asking for the destination city. After understanding that the user wants to go to New York City, the system asks for the check-in date. After a confirmation, the system reserves a room, ending the conversation. Although this dialogue is relatively simple, the system still needs to successfully solve some pretty challenging tasks. For starters, the system needs to convert the user's spoken words into a text input. Next, the keywords book and hotel need to be extracted. These commands is to be interpreted and the hotel routine is to be started. For each step in the hotel routine, a couple of steps need to be taken. If the reservation is not yet complete, a field that needs to be filled is selected. Then a question is formulated and converted to audio. Now that we have seen all the steps involved in keeping a simple dialogue, let's look at the high-level architecture of a conversational bot. The user starts talking with the system. The audio signal is converted to text by a speech recognition module. It outputs a text message, which is then further processed by the language understanding module. It assigns a form of meaning to a particular message. In a dialogue, this meaning needs to be viewed in light of the things that have been said before. This is the role of the dialogue understanding module. Now that the message is included in the system's understanding of the dialogue, it is ready to say something itself. Deciding what to say is handled by the dialogue management module, and turning this decision into actual text gets handled by the language generation module. Finally, the text message is converted into an audio message, which is played back to the user. Some of these components are available as off-the-shelf AI solutions. The speech recognition and generation modules, for example, are readily available in the form of cloud services and software packages. Others typically require handcrafting, and this can be labor-intensive, which hinders optimizing these modules using data. This video is specifically about the optimization of the dialogue management task using data. We will first look into how reinforcement learning works though. In reinforcement learning, an agent is situated in an environment. At each point in time, it observes the condition or state of the environment and takes an action. The action is performed in the world, which changes as a result. The result of this is the new state. Additionally, the environment tells the agent whether the selected action was appropriate for the environment state. It does so by giving the agent a reward. The reward can be both positive and negative, but is always referred to as reward. A trajectory of environment states, agent actions, resulting states, and corresponding rewards is constructed. The overall goal of the agent is to obtain as much rewards as possible. In order to achieve this goal, it must make sequences of the right decisions. For example, a sequence of moves in a simple maze environment, or deciding what to say next given the current state of the dialogue in a chatbot environment. And this is what we did in our experiments. We ran an experiment in which the chatbot was to recommend a product to a user in a simulation environment. In this environment, we modeled novice users that were not familiar with the product of interest and expert users. The novice users required more explanation before they could answer the bot's questions, whereas the experts knew the answer straight away. The bot was given a summary of the dialogue history as the state of the environment, together with the user's familiarity with the product. The bot could ask for user preferences and make recommendations. Rewards were given based on the accuracy and the speed of the recommendation. We then compared various reinforcement learning algorithms and a task-specific heuristic with a state-of-the-art approach based on information entropy. We found that the learning-based approach was able to learn how to personalize this interaction. It learned to ask specific questions straight away to experts, and it learned to give an explanation first to novices. Additionally, we found that the reinforcement learning approaches were able to complete the task successfully and efficiently, even when pre-processing modules contained errors. This is important because text-to-speech and language understanding tools typically have some margin of error. To summarize, the application of reinforcement learning to the problem of personalized dialogue management was successful due to three main factors. The problem of dialogue management is inherently sequential. An upfront optimal solution is not available, but data can help finding this optimal solution.